So electric field, I have assumed that is oscillating along the y direction, and I
Yes,
have
sir.
assumed that the magnetic field is oscillating along the z direction. But this
Yes,
can
sir.
be changed according to the equation. Somewhere you will find, somewhere you can find that electric field is oscillating along the z direction or x direction. Okay.
Yes.
So this is not mandatory. Okay. The equation of the electric field and the magnetic field can change. And after that we will have peak value of the electric field and the magnetic field. Peak value of the electric field and the magnetic field means you can see here the graph. Here this is the longest arrow. This is the longest arrow, na? Hello? Hello, Harsh. Getting my voice?
Yes, sir. Yes.
So see, basically, this arrow is the longest arrow means this corresponding to this value of x. This here will be the E naught. E naught is the maximum value of the electric field, and somewhere here will be the maximum value of the magnetic field also. Okay,
Yes.
B naught. B naught is the maximum value of magnetic field. E naught is the, so there is a relation between the E naught and V naught. E naught divided by V naught is equal to the speed of electromagnetic wave in vacuum. What is C? C is the speed of electromagnetic wave in free space or vacuum. Okay, this is the first relation. Just write down fast. So this relation will be used in solving numericals.
Yes, sir.
So light is also the electromagnetic wave. So basically, what is the
Yes.
speed of the light? 3 into 10 to the power 8 meter per second. Can write this also. Value of the C is 3 into
Yes, sir.
3 into 8 10 to the power 8 meter per second. And this value is in the vacuum free space, or you can say sometimes in air also. So you can write here in electromagnetic wave. In electromagnetic wave. Peak value of electric and magnetic field in
Done, sir.
electromagnetic wave. Okay, done. Very good. Now we know that there is a medium. Suppose the medium you can take the air as a medium. So air has the permeability. What is the meaning of the permeability? Mu naught is the permeability of the air, and there is one more term, permittivity.
Yes, sir.
So basically, free space or air have these permeability and permittivity. And if I am taking another medium like water, so water will have the permeability and permittivity. So basically, this
Yes.
is the permeability of medium and permittivity of medium. So now there is a relation between this and this. All these things have the relation. So this relation is very simple relation. Basically, if you are talking about the air, vacuum or free space, air, vacuum or free space, then there is a relation between the speed of light, or you can say speed of electromagnetic wave, light, or you can say speed of light, or you can say electromagnetic wave in free space. Speed of light or speed of electromagnetic wave, because light is also an electromagnetic wave. So speed of electromagnetic wave in vacuum or free space is equal to 1 upon mu naught into epsilon naught. This is the first formula you have to remember. Another, if you want to calculate the speed of electromagnetic wave in another medium, like in water, so what you will do? This will be the formula. In another medium, speed of the electromagnetic wave, or you can say light, is 1 upon mu m into epsilon m. What is mu m? Mu m is the permeability of the medium. Epsilon m is the permittivity of the medium. Okay.
Yes.
And there is a term that relative permittivity. Relative permittivity relates the relative permeability. The relative permeability relates the permeability of a medium with free space. So relative permeability is this. This formula, I think, okay. So this is the one formula, and this is another formula. Basically, this is the relative permittivity, and relative permittivity sometimes also called dielectric constant.
Yes, sir.
Dielectric constant. Okay. And what is relative permeability? Permeability of medium divided by permeability of free space. What is the relative permittivity? Permittivity of medium divided by permittivity of free space. And dielectric constant is also known as the relative permittivity. So in another medium, the speed of the electromagnetic wave is this. Now we will do one question on it.
Yes, sir.
This is a plane electromagnetic wave. Basically, this is the electromagnetic wave given. Electric field equation of the electromagnetic wave is given. So you know that there is the oscillating electric and the magnetic field. Okay, in the form of the sine curve. So the equation sine or cos you can say. So basically, electric field is given. So in a plane electromagnetic wave, electric field equation is given. Electric field propagates in a non-magnetic medium. So what is the meaning of the non-magnetic medium? Non-magnetic medium means that medium have the value of permeability equal to mu naught. Okay. So basically, in a plane electromagnetic wave propagates in non-magnetic medium of dielectric constant. Basically, we have to find the dielectric constant. So what is dielectric constant? Dielectric constant is equal to Em by E naught, means the
Yes, sir.
permittivity in the medium, permittivity of the medium in which the wave is traveling, and permittivity of the free space. Okay. Now just identify this equation. Basically, this value is E naught. Okay. E is equal to E naught cos omega t. I have told you, the equation can be changed. We can write the
Yes, sir.
equation E is equal to E naught cos omega t equal to E is equal to E naught sin omega t plus kx. E is equal to E naught sin omega t minus kx. So
Yes,
with
sir.
t there is omega, and with x there is k. Okay. So omega is this, k is this. So now speed of the wave, electromagnetic wave in the medium, speed of the electromagnetic wave in the medium is given by omega by k.
Yes, sir.
You can see here. Speed of the wave is omega by k. Okay. So omega by k. So you can find the speed of the wave in the medium, omega by k. And what is omega? Omega is 6 into 10 to the power 8. And what is k? K is 4. So basically
Yes.
you will get 3 by 2 into 10 to the power 8. And basically you will get 1.5 into 10 to the power 8. So what is the speed of the electromagnetic wave in this medium? That is equal to 1.5 into 10 to the power 8 meter per second. Okay.
Yes, sir.
Now there is one more formula to calculate the speed of the electromagnetic wave in medium, written here. This is the speed of electromagnetic wave in medium. V is equal to 1 upon mu m into epsilon m.
Yes, sir.
So speed of electromagnetic wave is given by, in the medium, 1 upon mu m into epsilon m. Epsilon m means permittivity of the medium. and
Yes,
mu
sir.
m is equal to mu naught, because this medium is non-magnetic medium. In which the wave is traveling, that medium is non-magnetic medium. So we can write this as 1 upon under root of, this is mu naught, or for epsilon m, there is a relation between the dielectric constant, that is epsilon m divided by epsilon naught. So from here we can calculate epsilon m, that is k times of epsilon naught. So we can write here k times of epsilon naught.
Yes,
Okay.
sir.
Now what value of Vm we have calculated? 1.5 into 10 to the power 8. So it is 1.5 into 10 to the power 8, and this will become 1 upon under root of k and 1 upon under root of mu naught into epsilon naught. What is 1 upon mu naught epsilon naught? Is equal to c.
C.
So basically c is, and what is c? C is 3 into 10 to the power 8 meter per second, and this is equal to 1 upon mu naught into epsilon naught. So basically this is 1.5 into 10 to the power 8, and here you will get uh, 1 upon mu naught epsilon naught is c. C is 3 into 10 to the power 8, and it will be under root of k. 10 to the power 8, 10 to the power 8 cancel out, it will become 2. Okay, so you will have root k is equal to 2. So from here, when you will square both sides, you will get k is equal to 4. So dielectric
Yes.
constant of the medium is equal to 4. Okay, so dielectric constant will not have any unit, because dielectric constant is the ratio of the permittivity of medium to the permittivity of the free space. Okay, now you
Yes.
can just write.
Second folder.
Okay.
Done, sir.
Okay. So with t time, there will be omega. The coefficient of time will be omega. The coefficient of x will be k. K is wave number.
Yes,
K
sir.
is wave number. Omega is the angular frequency.
Angular frequency.
Angular frequency of the wave. Actually, this k and this k have different things. Basically, this is another type of k. This k is the wave number. So I am writing here. This k is the wave number. Actually, so we have to remove this first. No, it's fine.
Yes, hold on.
Okay.
Done, sir.
Okay. So transverse nature of electromagnetic wave I have discussed here. Okay. So transverse nature of electromagnetic wave means the electric field is oscillating. Means you can say the electric field, magnetic field, and the direction of the propagation. The oscillation of electric field, magnetic field, and the direction of the propagation are perpendicular, mutually perpendicular to each other. So basically, this is a transverse nature of the electromagnetic wave. Okay. Now there is one more term here that I want to discuss. That is the refractive index of any medium. Refractive index of medium. Now, with the help of the electromagnetic wave, we can just find the refractive index of any medium. Okay, suppose the electromagnetic wave is traveling in any medium, and we want to find the refractive index. And from the 10th class, we know that the refractive index refractive index. So refractive index I will represent with small n. Refractive index is given by speed of light in vacuum, speed of, you can say, electromagnetic wave or light in vacuum or free space or air, divided by the speed of electromagnetic wave or light in medium, for which we are calculating the refractive index. So basically refractive index n can be written as speed of light in vacuum is c, and this is v, c by v. Now we have formulas of c and v. What is the formula of the c? 1 upon under root of mu naught into epsilon naught, and for v we have formula 1 upon under root of mu m into epsilon m.
Yes,
Okay.
sir.
Now we can just write it as like this. It is 1 upon mu naught into epsilon naught. It will become mu m into epsilon m. This is basically epsilon m, and it is 1. So finally it will become refractive index is equal to under root of mu m by epsilon m, mu m by mu m, sorry, multiplied by epsilon m by epsilon naught. What is mu m by mu naught? This is mu naught basically. What is mu m
Mu
by mu
m
naught?
by mu naught.
Yeah. Relative
Uh,
permeability.
Relative permeability. Mu m by mu naught is yeah.
Huh.
Relative permittivity, right?
This is relative permittivity. So
Yeah.
basically, this will be the refractive index of the medium. Okay. So n is the refractive index of medium. Okay. Please write down it.
Yes, sir. Done, sir.
Okay. Do you know what is energy density?
Yes, sir.
Eh,
J, right?
No, no, no. That
Oh,
is
that is
different
current
thing.
density.
Yeah, that is current density.
Energy density, like it should have the same definition.
No, means not the same. Means energy density is basically energy contained in a unit volume.
Per unit volume, yeah.
Per unit volume. Basically, energy density is energy. Don't write it. Okay, I will write this. Okay, so
Yes.
this is just for your understanding. Now, this is the topic that we are going to study. So I am explaining what is energy density. So energy density is basically energy contained in the unit volume, or you can say energy per unit volume. This is the energy density. Okay, so energy density symbol will be small u, we will use. Okay, and remember, energy density for the capacitor is half of epsilon naught into E naught, E square. What is E? E is the electric field. If you have a capacitor like this now, and this capacitor is charging condition, is in the charging condition. This is plus, this is minus. This has the plus charge. This is a positively charged plate. This is a negatively charged plate. So
Yes.
energy density of the energy density in between the plates of the capacitor is basically energy density of the electric field. That is given by the half epsilon naught into electric field in between the plates. Okay, and energy dense, and there is, if I am taking an inductor, and this inductor, in this inductor there is a current I, and we know that in an inductor along the axis there is a magnetic field B, and that magnetic field B is given by mu naught into small n into I. Now energy density in inductor will be the magnetic energy density, because this is due to the magnetic field, and that is
Yes, sir.
given by half of mu naught into V square. So these are some basic things that will be used. Okay, so now topic is the energy density. Energy density is basically the energy in the volume of the electromagnetic wave. Now we are discussing the energy density of the electromagnetic wave. So in electromagnetic wave, what is in electromagnetic wave? Electric field oscillation and magnetic field oscillation. So basically there is a electrical energy and the magnetic energy in the electromagnetic wave. Basically, electromagnetic wave contains the oscillating electric energy and oscillating magnetic energy. And these electric energy oscillation and magnetic energy oscillation are perpendicular each other and perpendicular to the direction of the propagation. Another point is that the electrical energy and the magnetic energy in the electromagnetic waves are equal. Both are equal. Both have equal contribution. Okay, and what is the source of the electromagnetic wave? Can you tell me? Source of electromagnetic wave.
So it's vibrating particles, right? Source
It's a
electromagnetic.
it's a particle. It's a
Vibrating
the
particles.
no. It is a accelerating charge particle.
Yeah, accelerating
And
charge and
accelerating, if the charge particle is accelerating, that can produce the
oscillating and
electromagnetic
or
wave.
accelerating charge.
Yeah, and remember, accelerating means oscillating also, and means you can say that, and from where we get the oscillating charge, from the LC oscillation, and that is from the LC circuit.
Yes,
LC
sir.
circuit means when we are connecting a charged capacitor to the inductor,
Yes.
then oscillation of charge V. So basically, these are the theory. This is the theory. So basically, electromagnetic wave carry energy as uh, they travel through space. Thus, energy is contained in oscillating electric and magnetic field. This point you already know.
Yes, sir.
Okay. In electromagnetic wave, there is oscillating electric and magnetic field. Equal amount of energy is contributed by the electric and magnetic field. This point I will prove later. Okay. This point I will prove later. And we know, by now we know that electromagnetic wave produced by the oscillating charge in LC circuit. The energy of the electric field is from the capacitor. From the capacitor, what we get? The electric energy, and
Yes, sir.
from the inductor, what we get? The magnetic energy, or okay, energy of the magnetic field. Okay. So now just please note down this first. Have you noted down this first? Refractive index? Okay, completed.
Yeah, refractive index.
And mathematically, we will see how the energy density we can calculate for the electric field in electromagnetic wave and magnetic field in an electromagnetic wave. So after that, we will see what is the value of the energy density corresponding to electric field.
Okay.
And after that, we will see the what is the energy density corresponding to magnetic field. So electric field energy means is contained in between the plates of the capacitor. There is a electric energy and magnetic energy we get from the inductor. And I have done both the derivations also in electromagnetic induction. I have done the energy. I have calculated the energy density for the inductor, and in the chapter capacitor, I have just done the derivation of the energy density for the capacitor. That is energy density corresponding to electric field.
Done, sir.
Done. Okay. Okay. So energy density of electric field. So basically, this is a capacitor. Okay, this is one plate of the capacitor. One plate. This plate is positively charged, and this plate is negatively charged. Okay, this plate is negatively charged. Okay, and this capacitor is in the charging condition right now. Okay, charging condition right now, and we know that in if this is the this capacitor is in the charging condition, then the electric field in between the plates of the capacitor will variable. Why variable? because because electric field in between the plates of capacitor is given by surface charge density on the plates of the capacitor divided by the area of the plate. And what is surface charge density? Oh, electric field is given by sigma by epsilon naught actually. This is the formula, na? Electric
Yes,
field
sir.
in between the plates of the capacitor is sigma by epsilon naught. And this, what is sigma? Sigma is, suppose Q is the charge here on the plates of the capacitor. Here is plus Q, here is minus Q. So you can write charge divided by epsilon naught into area. Charge by area is this. Okay, so electric field in between the plates of the capacitor is Q by epsilon naught into A. So now this charge is increasing or changing. So you can say that the electric field is also changing.
Yes.
Okay. The electric field is also changing. So the equation of the electric field is this. In case of the electromagnetic wave, the electric field is this. E is equal to E naught sine kx minus omega t. This electric field is changing. Okay, this electric field is changing.
Yes, sir.
So now there is no requirement of this. Basically, this formula you should know, energy density of electric field. Okay, so in between the plates there is a electric field. Now we are just calculating what is the energy density corresponding to this electric field. So basically the energy density corresponding to this electric field is half epsilon naught into E naught square into E square is the electric field. Okay.
Yes,
And
sir.
now in an electromagnetic wave, what is the variation of the electric field is given by E is equal to E naught sine kx minus omega t. This is the equation of the electric field in electromagnetic wave. Now put this value here in this equation. Put this value in this equation. So you will get half epsilon naught into E naught square. E naught square means this is square, this
Yes,
term
sir.
is square. So this term is square means you will get E naught square sine square kx minus omega t. Now this is what? This is the energy density corresponding to electric field. This is energy density corresponding to
Electric
electric field.
field.
Is this constant value or this is the variable value? This.
This is constant, right?
No, this is not constant because this sign is not constant.
Oh
This
yeah, the angle is not constant. The
this
angle is not constant. Yeah.
epsilon naught is constant. This E naught is constant, but this sine kx minus omega t is not constant
Not
because
not
see,
not constant.
yeah, because electric field is a function of x also, and electric field is a function of time also. So what
Yes.
we will do, we will take the average. We will take average. We will average. I represent like this average. Earlier also we have calculated the average part. Okay, and there is one more thing that you should know: the average value of sine square of any theta for full cycle is equal to 0. Okay.
Yes, sir.
This also I have already told you in the last chapter. So you are calculating the average energy density, that is UE average energy density corresponding to electric field. This half is constant, epsilon naught is constant, this E naught square is again constant, and the average of, you will take sine square kx minus omega t. Why I have taken this value out of the bar? Because this value is constant value, and for a
Yes, sir.
constant value the average is the same. Okay, so average of this will be this same value. Now average of this will be half. Sine of any angle here, sine square of any angle average for full cycle is equal to half. So the average energy density for the electric field is equal to half into epsilon naught into E naught square, and it will be 1 by 2 again. So what will be the energy density corresponding to electric field? That is 1 by 4 of epsilon naught into E naught square. So this is the energy density corresponding to electric field. Okay, energy density corresponding to
Yes.
electric field.
Yes, sir.
So how we have calculated? First we have calculated the energy density for the electric field. That is half epsilon naught into E naught square. And after that, what is the value of the electric field in electromagnetic wave? What is the equation of the electric field in electromagnetic wave? E is equal to E naught
Yes, sir.
sine omega t sine kx minus omega t.
Yeah,
We
and
have
then you
put this
put the
value here,
equation in the energy density.
and then we have taken the average. And finally we are getting half epsilon 1 by 4 epsilon naught into E naught square. Basically this is the average energy density, average energy density for electric field Now, same way you can calculate the energy density of the magnetic field. Okay. For the magnetic, first write this, then we will go for the magnetic field.
Yes, sir.
And this capacitor is parallel plate capacitor.
Second scroll down. Done, sir.
Okay. So in the same way, we can calculate the energy density for the magnetic field. Okay. Energy density for the magnetic field. So energy density for the magnetic field, basically this is the inductor. Okay. In inductor, we know that the magnetic field is along, magnetic field is axial inside the solenoid or inductor, you
Yes,
can
sir.
say, of length L. So basically, I have just derived this. If you have remembered, I don't know. In the chapter electromagnetic induction, I think I have derived, I know. Okay. So energy density for the inductor is this. This we have derived. Okay. Derived now. Energy
Yes,
density
sir.
for the inductor. You can see here. and energy density for the inductor, or you can say solenoid, that is given by mu naught half mu naught into b square. B is the magnetic field. So basically half uh, 1 upon 2 into mu naught into v square. And what is the equation of the magnetic field in electromagnetic wave? V is equal to v naught sine kx minus omega t. You
Yes,
can
sir.
see here equation of the electromagnetic wave. For the equation of the electric field, E is equal to E naught sine kx minus omega t. For the equation
Yes.
of the magnetic field, V is equal to V naught sine kx minus omega t. Okay, so energy density of the magnetic field is this. Again, you will put the value of this magnetic field in this equation, so you will get this. And now you will, and this value is a variable value because here time is changing, because the magnetic field is changing with time and with the distance or with the x. And you can say that this, as this time is changing, so you can say this is variable value. This energy density of the magnetic field is variable this time, and you can say that when you will calculate the average value, okay, so this will be the average value and this term will be the constant term, so you can take right here, because the average of constant is again that constant, and the average of sine square is half, so that will be written as like this, 1 by 4 epsilon. So this is the average value of energy density of magnetic field, that is 1 upon 4 mu naught into b naught square. What is b naught? What is b naught? B naught is the
Magnetic
peak value,
field, peak of the
peak
magnetic field.
magnetic field. Okay, so peak value of the magnetic field. Okay, write down. And remember that the magnetic field for the solenoid is given by mu naught into number of turns per unit length into current in the solenoid. B is equal to mu naught into I. And this magnetic field is axial inside the solenoid.
Yes, what?
Hmm.
Tensor.
Okay. So we have seen the energy in electromagnetic wave corresponding to means the energy density in an electromagnetic wave corresponding to electric field is given by half of epsilon naught into E naught square, and
Yes,
the
sir.
energy corresponding to magnetic field is equal to 1 upon 4. Oh, this is not 1 by 2, this is 1 by 4. So this is 1 by 4, and here is 1 by 4, 1 by 4 mu naught into B naught square. What is E naught? Harsh, just tell me fast. What is E
Sir,
naught?
the peak value of peak value of electric field, right?
No, no, this I am asking this value.
Oh, epsilon naught.
Epsilon naught.
Epsilon naught is
I have told you that E naught.
yeah, you told E naught.
Okay,
That's
okay, okay.
why
Okay, actually I was asking this. Sorry. E
epsilon
naught.
naught is a peak value of
No, no, it is not a peak value. Basically, this is the permittivity
yeah,
of,
permittivity of free space like
yeah.
8.85 to 10 raised
What
to
is E
minus
naught?
9.
What is E naught?
Peak value of
Uh-huh.
electric field.
Okay. And what is this?
So that's mu like
This is not mu e. This is u, small u suffix e, energy
yeah,
density for electric field. Average
energy
energy
density
density.
of electric field. Yeah.
Uh, what is mu? This is mu naught.
Sir, permeability of free space.
Yeah, very good. And what is V naught?
Sir, magnetic field, big magnetic
And
field.
what is this?
A magnetic
Average.
average
Magnetic.
average magnetic field
Yeah.
density, right?
You are right.
Average
Means
magnetic field.
energy. You can say energy density of magnetic field.
Yes.
Okay, or you can say average energy density of magnetic field. After this, we will calculate the total energy of electromagnetic wave. So in electromagnetic wave, there are two types of energies. In electromagnetic wave, total energy of the electromagnetic wave, total energy of the electromagnetic wave, total energy density, sorry, total energy density of the electromagnetic wave, small u suffix t. Basically, you have the electric energy density
Yes, sir.
and you have the magnetic energy density. Is it or not? These two
Yes,
energy
sir.
you have.
Yes.
Okay, so what we will do, first we will see whether both energy densities are equal or not. Okay, so we will check. So left hand side, uh, sorry, I am writing here this, whether energy density corresponding to electric field is equal to energy density corresponding to magnetic field. So basically this is the question. So we will see, is it there or not. So
Yes,
what we
sir.
will do, basically you can take this as a question. Now you can just say, you can first, you will take left hand side, and in left hand side you have the energy density of electric field, and formula half of epsilon naught into E naught square. Now there is a
Yes.
relation between E naught and V naught, that is equal to C. So from here you can calculate E naught, that is equal to C times of V naught. Okay. So here you can write half of epsilon naught, instead of this E naught square, you can write E naught square is C naught square into B naught square. So
Yes,
you can
sir.
write this is V naught square into C square.
C square.
Okay. V naught square into C
C
square.
square.
Now there is a relation C is equal to 1 upon mu naught into
mu
epsilon
naught
naught.
epsilon naught.
When you will do c square, it will become 1 upon mu naught into epsilon naught. Okay. So it is half epsilon naught b naught square. What is c naught square? 1 upon mu naught into epsilon naught. So now this epsilon naught finished, and finally you will get half of mu naught into b naught. Oh, what is happening here? Actually, here will be 1 by 4. Okay, with average energy density for the electric field is 1 by 4, na?
Yes, sir.
Okay, okay, that is why the answer is not correct. Here is 1 by 4. So here is also 1 by 4. So finally, here also you will have 1 by 4 of V naught square. So what is 1 by 4 mu naught of V naught square is equal to magnetic energy density of the electromagnetic wave. So basically,
Yes, sir.
you can say left hand side is equal to right hand side. Okay, you can say left hand side is equal to right hand side, means you can say the energy corresponding to the means the energy density corresponding to the electric field is equal to the energy density corresponding to magnetic field. So these values are equal, remember.
Yes, sir. Right, sir.
So these values are equal. Now we want to calculate the total energy then. Total energy for the electromagnetic wave. Total energy of the
Yes, sir.
electromagnetic. So total energy of electromagnetic wave, total energy density. Total energy density in electromagnetic wave is equal to the sum of the electrical energy density plus magnetic energy density. And we
Yes,
know
sir.
this relation. Electrical energy density is equal to the magnetic energy density. So I can write in terms of this. First, I can write this plus. So in terms of this value, I can write this value
Yes, sir.
because both are equal. So I can write this value. So it will become 2 times of energy density of electric field, and it will become 2 into, and what is energy density of electric field? 1 by 4 of epsilon naught into E naught square. So finally, the total energy of the electromagnetic wave is given by 1 by 2 of epsilon naught into E naught square. So this is the total energy of the electromagnetic wave in terms of the magnetic field, in terms of the electric field. Okay.
Yes, sir.
One more way you can just find the total energy. So total energy again you can write is equal to total energy of the electric field plus total energy of the magnetic field. So now you can write this as total energy of magnetic field. Okay. Total energy density of the magnetic field, you can write this is basically the magnetic field. V, and here will be the average. So total energy density of electromagnetic wave is equal to the electrical energy density plus magnetic energy
Magnetic
density,
field density.
and both are equal. So I can
Yes.
write in this term also. So 2 times of the average magnetic
Magnetic field
energy
density.
density, magnetic field density or magnetic energy density.
Yes, sir.
So what is the formula of magnetic energy density? 1 by 4 of mu naught into B naught square. So total energy density of electromagnetic wave can be given as 1 upon 2 mu naught into B naught square. This is the another formula for the total energy density. Okay, so you can now basically conclusion is that the total energy density is equal to half of the means total energy density is equal to half of the electrical energy density and half of the what I am saying. Actually, this is not correct. Total electrical energy density is equal to total magnetic energy density. Both are equal, and this is equal to the total and half of the total energy. Okay. So basically, if you are getting this, means remember only this formula. Okay, you can drive this. Okay, but you should know what is the average energy density for the electric field or for
Yes,
the
sir.
magnetic field. So now you can just note down.
Sir, how many topics are left?
Basically, this was the. I have to see. Few more topics are left. Means it will take at least 1 more hour, and after that it will be finished. So, are you available? Will you join the class on Tuesday?
Yeah, I'll do it on Tuesday.
Okay, fine. Then no problem.
So this class is 1.5 hours, right?
Hmm?
This class is 1.5 hours, right?
If you want, then it can be of 2 hours also.
Sir, actually, I have to do project.
Okay, no problem. So it will remain of 1.5 hour. So, what type of project you are just?
Sir, this is
Uh,
I actually have to do 3 projects: computer, chemistry, and physics. Like it's
so,
group projects, I have to do my
so
work and send them.
in physics, what topic you are doing?
Sir, we are doing a future of lithium batteries.
Lithium batteries. Okay. So
Yeah.
actually, this topic I think should be related to the chemistry by
Yeah,
physics.
it should, like it's in electrochemistry, but it's in physics.
It should basically the topic of the chemistry. Maybe in the physics there can be some phenomena. Basically, battery is the electricity, na? In battery we have
Yeah, yeah,
electricity,
yeah,
so
yeah.
that is why it is related to. This is very famous project topic these days. Lithium battery.
It is easy, so that's why everyone picks it.
I don't know whether it is easy or not, but
No, like
most of the
everyone is,
students.
it is just theoretical. You just copy paste from Google.
Okay, and
Like,
in
like it's a group project for us. Like if so, it doesn't matter. But
okay, so in computers, what is your project means? What you are
so it
doing
is
there?
a data management system. So you have to make a code and do it.
Okay. And in chemistry?
Chemistry, it's about efficiency of this thing. Wait, just a
Okay,
minute.
okay. I know that. Understood. Efficiency of that S2O2 type push, something like that. Oh,
Yeah, it's efficiency. No, efficiency of sanitizer in microbes.
oh, okay.
Like we were going to do that carbonated drinks, but we changed it.
Okay. So remember, these projects are very important part.
Yeah,
Means when you will go in higher education also, projects are always important, but students does not give the value to these projects because they think that we can copy and paste and all that. But believe me, these projects in future will help you a lot because in future you are not going to get the energy density and all that thing. If you will get if you will be in teaching like me, or you will get if you are doing some research. Okay.
Yeah.
So otherwise, in corporate world, if you will do the job, it means if you are going in computers, okay. So there will be no electric field, and there will be no magnetic field. There will be only codes, and there will be the projects basically. So there you have to complete the project given by your manager. So basically, so that is quite important. Means you should know how to work in a team also. So
Yeah.
in job, when you will find, I don't know whether you will do the job or something else. So for a person that will do a job, project management and these doing the projects and attending the seminars and all these things are just quite important in the school also. So apart from the studies.
Done. Second, scroll down.
Done. Okay. So if you will join the classes now, Tuesday and Tuesday, Tuesday and Thursday, then basically we will finish the in two lecture, the reflection of light. Okay, the reflection of light will be finished in two lectures basically.
Reflection of light.
Yeah,
Like that chapter, wave, ray optics.
yeah. Mean not the refraction part. Ray optics will be in ray optics. We have the
Yeah.
reflection,
Okay.
and we have
Reflection part
refraction.
we finished.
Only the reflection part is completed in those two
Oh.
lectures.
Okay.
Mostly you have to study the refraction.
And this chapter also will finish in next class.
Maybe this will be finished today also. In we will see.
Sir, but it will 1 hour, right?
Uh, no. I think it will take at least. It will take 1 hour because you are writing now. If you
Done, sir.
okay, fine. So there is one question. Uh, a magnetic field in a plane electromagnetic wave. This is the equation of the magnetic field. Now you know in electromagnetic wave there is magnetic field.
Yes.
So see, this is the magnetic field in an electromagnetic wave. This is given, and find. They are asking find average energy density. Find average energy density corresponding to electric field. So what is the average energy density corresponding to electric field? Average energy density corresponding to electric field is equal to half 1 by 4. Sorry, 1 by
1 by
4.
4 epsilon naught E naught square.
Very good. E naught square. And what is the average energy density? And this value, average energy density of electric field, is also equal to the average energy density of the magnetic field.
Yes, sir.
For solving numerical,
Is that B is equal to 200 RT?
hmm?
The magnetic field is equal to 200 RT.
This is not RT. This is micro Tesla.
Oh, that's
This is
micro. Micro.
this is micro. Yeah.
So looking like R, sir.
Okay, this is micro Tesla. Okay, so this is equal. So this value we have is B naught value. Peak value of magnetic field is micro Tesla. 200 micro
Yes.
Tesla is there. So we want to find this value. So this value is equal to this value, and this value is given by half of.
And then that is
Do you know
R by C.
where
That's
is
N by C.
X by C?
X by C.
I have told you, na, there will be
Yeah,
X.
yeah, yeah. Yeah.
If If x is given and here is the negative sign, means this wave is traveling towards positive x direction. Okay, and with time, when you will multiply this now, when you will, I'm not going in that because question will be solved from here also, here only. There will be no requirement. If you are asking that in detail, then when you will multiply this, so with time you will get this value, and this value will be omega. I have told you the coefficient of time is omega
Omega,
in wave equation,
yes.
and the coefficient of x you will get, the coefficient of x you will get is wave number k. Okay, so I'm not going in that. I have just solving the question because we need a peak value of the magnetic field to solve the question, so we can solve that question. And for half of epsilon, this is not half, this is 1 by 4. Again and again I am writing half. So this is 1 by 4 mu naught into v naught square. So you can calculate this 1 upon 4. What is mu naught? 4 pi into 10 to the power minus 7.
Yes,
And
permeability of free
yeah,
space.
and B naught is 200 micro Tesla. 200 micro means 10 to the power 6 and square. When you will solve it, you will get 8 into 10 to the power 3. 10 to the power minus 3 joule per meter cube. Why joule per meter cube? Because this is the energy density. So energy unit is joule. And energy density means energy per unit volume. So this is energy is joule, volume is meter cube. Okay. So you can now note down this.
So can you zoom out?
Zoom out, yes. Fine.
Yeah. Done, sir.
Done. Okay. So after that, the intensity of the electromagnetic wave. Intensity. Basically, intensity is different from the energy. So basically, what is intensity? Energy crossing per unit time, per unit area in a direction perpendicular to the direction of the propagation of the wave is called the intensity of the wave. So basically, now for example, this is an electromagnetic wave, and this electromagnetic wave is crossing this area. Basically, this is the area you can see. This is the area A, cross section area, and this electromagnetic wave is entering to this area. And at this end, suppose at t is equal to 0, this wave entered. And at t is equal to t, we are just analyzing this cylinder. Basically, this is the imaginary cylinder. This is the imaginary cylinder. So in this imaginary cylinder, just we are analyzing the cylinder for t is equal to 0 to t is equal to t. Okay, we are analyzing this as this is the electromagnetic wave and there is a vacuum inside the cylinder. So this electromagnetic wave will have the speed of c. C is the speed of electromagnetic wave. So as the electromagnetic wave is traveling from this area, this cross section to the this cross section, so we can find this distance. Distance is equal to speed of the electromagnetic wave and the time taken to reach the electromagnetic wave from here to here. Okay. So this will be C into T. Are you getting?
Yes, sir.
Basically, what is happening? This is the electromagnetic wave crossing this area. So basically, we are analyzing the amount of energy crossing this area in time 0 to t. Okay. So how I have calculated this distance CT? Because we are analyzing the system for 0 to time t. We are analyzing the system for 0 time t is equal to 0 to time t is equal to t. So
Yes.
basically, we can say that this distance is given by speed of the electromagnetic wave. The electromagnetic wave is moves with a speed c in vacuum, and
Yes, sir.
time is t. Okay, from here to here, time taken to travel wave is t. So that is why this distance is ct. Now, if I want to calculate the volume of this cylinder, volume V of the cylinder, I can calculate. That is given by area into area into length of the cylinder. So length of the cylinder is ct. So area is ACT. Now energy density of electromagnetic wave. Energy density of electromagnetic wave is basically the energy contained in a unit volume of electromagnetic wave.
Yes, sir.
Means see, if I want basically intensity is the energy. Intensity is basically energy, not energy density. Energy divided by area divided by time. Okay, energy divided by area divided by time. So first I want to calculate energy in the unit volume of this cylinder. So energy in the unit volume of this cylinder is basically the energy density of electromagnetic wave.
Yes, sir.
Energy density of electromagnetic wave. And what is the energy density of the electromagnetic wave? That is equal to half of epsilon naught into E naught square. This is the energy density of electromagnetic wave.
Yes, sir.
And so what is this? This is the energy in the unit volume of the cylinder. And for the total volume, the amount of energy contained in time uh, 0 to t will be basically this is the energy density. This is the small u. Okay. So total energy contained is equal to capital U is equal to small u into the volume. Okay. And this is equal to half of epsilon naught into E naught square, and volume is ACT. You can see the value of volume. Volume is ACT.
Yeah,
So this is the
area into city.
this is the total energy filled in this cylinder in time t.
Yes, sir.
This is the total energy filled. Now we want to find the intensity. So what is intensity? Intensity is the total energy divided by the area of the cross section from which the energy is passing perpendicularly, and for the time in which the energy is passing perpendicularly. So it will become half of epsilon naught into E naught square into ACT. This is divided by A into T. So now which is cancelling? This A cancelling, this T cancelling. So intensity of the electromagnetic wave is basically given by half epsilon naught into E naught square, is basically the energy density of the electromagnetic wave into this C.
Into C.
Okay, this C. So
Yes,
basically
sir.
this is the intensity of the electromagnetic wave. Intensity of the electromagnetic
Electromagnetic
wave.
waves.
Intensity of electromagnetic wave. What is U here? U is the energy density of electromagnetic wave. Energy density of electromagnetic wave. What is C? C is the speed of
Speed
electromagnetic
of electron
magnetic wave in
in
vacuum,
free space. Yeah.
free space, or you can say vacuum also. Vacuum, free space, and the C is given by 3 into 10 to the power 8 meter
8
per
meter per
second.
second.
Okay, okay, note down. So basically, remember one thing here: the energy that is crossing in time t from this area will be the energy contained in this cylinder.
Yes, sir.
Hmm.
Done, sir.
Today you are writing very fast.
Yeah.
So do you want to leave the class or should I continue?
Actually, sir, I have another meeting, sir, for the project with
No,
my
no, no
friends.
problem. It's fine. It's fine. It's fine. Okay, no problem. It's
Once
your
the
choice.
projects are done, like I just have to submit. That's it.
Okay, it's fine. It's fine. Basically, see, this value is 3 into 10 to the power
Yeah,
8 meter per second. Okay.
8 meter per second.
Okay. So we will meet in the next class. Okay. If if you will attend the class, then we will meet in the next class.
Yes, sir, I'll attend, sir.
Okay, no problem. Fine. And at the same time of the project and all now I know your exams are coming. There are n number of things simultaneously you have to do. I know that.
Yes, sir.
Okay. So what you have to do, you have to try to manage your time and do not waste time. Okay.
Yes,
In
sir. Done, sir.
the okay. And simultaneously you have to continuously you have to revise revision also. You have to do the revision also.